Hello YouTube, my name's Rob Pollard, and the purpose of this video is to provide an overview of the mapping system used in Ancient Armies. Before I show you the maps there, I want to show what I was trying to achieve first, just to give you an idea of why the maps look the way they do. If you open any historical textbook or even go on the internet, a lot of ancient battles kind of look like this. They're on fairly simple maps which show things like hill contours and other terrain features, and the units tend to be shown as blocks. And this is pretty much what I was trying to go for. But of course, being a game, my system would need to know that this was actually a hill and make the units react to that hill in the correct way, and line of sight would have to work as well. One of my early requirements though, when I decided to put the mapping system together, was that I wanted the ability to be able to continuously zoom in onto a map without losing any detail, and that's quite a big ask. For example, if we take this map here, if we keep zooming in, look what happens to the image quality. It starts to get all jaggy and it starts to break up. So obviously I can't use or couldn't use standard pictures for my system, so that requirement drove me towards making the entire mapping system vectorized, and in effect everything in the mapping system is a mathematical model rather than the picture, and I'll show you that, and I'll show you the advantages that provides. Architecturally speaking, everything's held with a .NET map library, and any .NET application can use this library and get all the mapping functionality for free. In the case of Ancient Armies, I have three applications that use the map library. That's the editor, which I'm going to show you now, the scenario editor, and Ancient Armies itself. And these three apps don't know anything about maps at all. They don't know how to draw them. They don't know how to react to them. All they do is they consume this DLL, and this library provides all that functionality for them. And of course, if at some point in the future I decide to create another application that I want to use these maps, I just point it at this map library and away I go. So it's a pretty powerful architecture. Anyway, let's show you how these maps are created. The system comes with this map editor. The map editor is actually a paper thin application. There's not much code in it. A lot of the code's going off to the mapping library, which I showed earlier. So what I'll do now, I'll create a very simple map with a few terrain features. I'll just show you how easy it is, and also to show off some of the features of this system. So let's create a new map. Call it test map. I'm going to leave the rest of the settings on default, so I'm going to leave it at 3 kilometers by 3 kilometers, so we can change that. And I'll show you image overlay imports later on, so let's hit OK. So there's our map. It starts off fairly featureless. So I'm going to do now, I'm going to add a 3-tiered hill, just show how easy it is to do. So what we do is click Add Contour. We're going to make it Bezier, and all that means it's going to make it curvy, and then we can draw in our hill, and it is just as simple as drawing. No technical skills required at all. So that's one hill contour. Of course we can add more. Don't worry about the colours, so I'm kind of randomly picking these for the moment. We will change them later on. Let's put in contour number 2. And then finally let's add our last contour, contour number 3. Get on bright yellow, and that. So there you go. That's our hill with 3 contours. Very simple to produce. Didn't take me long at all. That's pretty much seconds really. Now what I could do right now, I could go to each of these contours, change the colours and change the elevations. The downside of doing that though is if this was a very large map and I had numerous hills, it would be quite difficult to make sure that all the elevations had the correct colours and that they all matched. So to that end, the system supports the concept of elevation keys. What these do, they allow you to define or predefine contours for a particular map. And it's as simple as you pick a starting colour. Let's make that light green. Pick an ending colour, and we'll say brown. And then you add as many contours as you wish. And it automatically calculates the colours between those contours. And then you can do things like add the actual contour levels for each contour. And they could be anything you want. They could go up in hundreds of meters or tens of meters and so forth. It's very, very simple. I'm not going to use this for. What I'm going to do instead is load up some that I've created earlier. So I'll show you some bits and bobs. So here's a European one. This one has 4 contour features in it and 1 base level, and it goes up in increments of 10 meters. So hit OK. Now that's in the system now. What I need to do is assign it. So set ground level to 0, contour 1 to 10 meters, contour 2 to 20 meters, and contour 3 to 30 meters. And the beauty of the system is that regardless of how many hills I have, provided I set up the correct key, it will automatically give it the correct elevation, the correct colour scheme. And of course, by using elevation keys, the colours flow a lot more naturally. So it's a very powerful system in that respect. The other advantage is, if I decide I don't like the look of this, well, I actually want to change the look and feel, I can quite simply just change the elevation keys. I can either do it manually or even perhaps load in a new one. In this case, we're going to load the Ancient Armies scheme I'm going to use for the maps. Hit OK, and straight away everything changes that quick. So it's really, really simple, very, very powerful. This grid's a little bit too strong. I'm just going to turn down the grid. So let's turn it down. Everything's configurable with this. I could change the grid colour, make it opaque or not, hide it. Same with the scale, could hide it, change its colour, all sorts of things we could adjust. Now, the big advantage Ancient Armies mapping system has over standard wargame systems is that what you're viewing here isn't a picture. It's actually a mathematical model that's calculated on the fly, and that provides numerous advantages over a traditional wargame. The first advantage is pixel perfect terrain detection. In a traditional system where the map is a picture, those systems tend to have a separate data structure which tells the game where the various terrain types are. And of course that never fully matches the actual map. So what actually happens is that you can get situations where you hover your mouse over what looks like, say, a wood, but the map's reporting back it's actually clear terrain. And that's because the picture of the map doesn't match the underlying data. And that happens quite frequently. But with this system, because what you're seeing is a rendered mathematical model, you are looking at the data itself. And because of that, you'll always get pixel perfect terrain detection. I can show you that now. If you look bottom left here, this shows you what terrain the mouse cursor is currently over. So as I move it over, you see 10 meters, 20 meter contour and 30 meters. But even when I zoom in, and even on a curve, it's pixel perfect. So if I move the terrain cursor very slowly across the boundary, you should see that switch up to 30 meters. There you go, pixel perfect. There's not many other wargame systems that will do that because of the way, well, because they're static pictures. The other advantage of this being a mathematical model is that it allows me to continuously and smoothly zoom the map, and I can zoom all the way in without any loss of detail. Everything is really, really razor sharp. Whereas had this being a picture, as I showed earlier, you get lots of breakup, whereas here it's completely sharp all the way down, no matter how close you zoom. So that's another very, very powerful feature of this system. Of course, it wasn't easy to create this because all these curves and things, they're really triangles, because direct 3D can only draw triangles. So I have to actually calculate the triangles to fit these curves. And I can actually show you what that looks like. I took a screenshot of the mapping system without it filling in the shapes, so you can actually see the triangles. And every one of these triangles has to be calculated on the fly, so basically it's a lot more complex than it looks. But by investing my time in producing the system, I have lots of advantages which a traditional system doesn't have, including smooth continuous zooming with no image breakup, and also pixel perfect terrain detection, so it was worth it even if it was a little bit complex. Now the other advantage of this being a mathematically created model rather than a static image is that if I don't like something, I can edit it, which you can't do on a static picture. So say I want to alter how contour 2 lies, I can simply select it, click edit, and then move things around. And there you go. You can't do that with a static picture. So that's one big advantage. Another advantage is because this is the data, you can perform various calculations on it, like working out line of sight. So I click the line of sight tool. So our chap stood here. Where it's green, he can see all the way up the front face of this hill, and then from there downwards, where it goes red, his view is blocked. We can you get all this for free. Whereas again, the more traditional system, they have to spend a bit of time adding, I guess, artificial data to work out where the hills and things are for line of sight. But as you are looking at the actual data here, there's no need to do that. It's all built into the system. Of course, I can add other terrain very simply. Let's add some woods, for instance. So let's make the outline Bezier based as well. Just draw them in where you want the woods to be. Give it a few seconds to run the calculations. There you are. You got woods. And again, the terrain detection works fine with that as well. So if I move my mouse cursor over it, you can see bottom left, it's detected that as woods 1, and woods 1 contour level 1. Now another feature of the mapping system is that I can allocate names to things, like this wood, although it's called woods 1 right now, I can actually give it a name. So let's give it a name like Ley Woods. And what this means now is when the mouse cursor goes over it, when you look bottom left, you'll see it as Ley Woods. So in a game, people actually be able to see meaningful names for the various pieces of terrain that they're on. And you can do the same with the contours as well. If I were to call this hill Sugarloaf, I'd simply go to all the contours and actually name them Sugarloaf. There we go. So now when we move our cursor over it, say here, you can see bottom left that our location is Ley Woods, Sugarloaf, and we're at 20 meters elevation. That makes for much better presentation for the user in the game, and they can actually see the name of the terrain that they're hovering over without having to have perhaps labels. Although this does support labels, you can add them if you wish. So very, very powerful feature in that respect. The other advantage of this technology is it's very smooth. One of the issues I've always had with traditional war games is that the maps tend to scroll in a very jerky type fashion, whereas this is pixel perfect liquid smooth when you move around it. And again, that all adds to the feel of quality, which perhaps you don't get with some other games. Another feature of this is, as you've noticed on the right here, as you add terrain, it gets its own entry in here. And I showed you earlier that you can edit it, but nearly everything is configurable. For instance, the woods. Right now, the background of the woods is opaque, but I could change that. So I could give it like a background like that. and I can do things like change that background's colour. If I don't like that, I can maybe go for a more browny colour. I'd even change the colour of the woods themselves. Maybe we'll make them black. So everything is configurable to quite a large extent in this system, and that makes a very configurable maps. So that's a basic map. I say many advantages over traditional systems. Looks like I can continually zoom in as close as I want without any image breakup. I get automatic terrain detection, that's pixel perfect, and I get line of sight. So here this chap can see partly into the woods and his line of sight's blocked, and I get all that for free. What I'm going to do now, I'm going to show you the other way you create a map, and that's by importing an overlay. So let's create a brand new one. Test 2. And what I'll do now, I'll import an overlay of a picture that I downloaded from the internet. And in this case, we're going to go for a marathon, which is that one there. So there's the marathon map that I downloaded off the internet. Now, to pull that into the system, I need to register its scale. So we pick up a scale. So this one here goes from 0 to 1 mile. That's its particular scale there. So I can leave that on imperial miles. What I do then is click register scale, click on the key, and then register the other end. There you go. So it's detected that's what the real width, the depth of this map is in meters. Hit OK. And you notice it's filled that out here as well, though I can override that. Then we hit OK. There you go. That map is now imported into our system. Now, why would you want to do this? Well, there's several reasons. One reason might be you might actually want to play on this map as it is. And that's gives you the ability to effectively change the look and feel of your maps quite drastically by importing pictures like this. But of course, the downside of this is because this is a picture, not a mathematical model. Watch what happens when I zoom in. See how the image breaks up and gets very, very fuzzy? And that's one of the reasons why a lot of commercial war games that are out now only give you 3 or 4 levels of zoom, because if they get in too close, things break up. Now with my system, that doesn't occur, and I'll show you that in a second. Let's again turn the grid down a bit because it's a bit too overpowering. Well, what I'm going to do is I'm going to show you a way of taking advantage of this map that we've imported, in that what we can do is use it to create our own vectorized maps and use it as a guide to effectively enable us to produce maps that are as accurate as the maps that we import. So what I'm going to do, this stream here, I'm going to recreate this using our mapping system. It's all quite easy to do. In fact, let's put this into 3D mode. Right, so I click add stream, and then I just click where the stream is. Now, normally when you're creating historical maps like this, you'd kind of like take your time over this, but this is a quick demo, so I'm kind of rushing this a bit, so it might not be as accurate as it could be. But if you took your time over this, the map you create can be as accurate as the historical one that you imported into the system. So it is a great way to create historical maps that are well, that look correct. So this is our stream. Let me just edit that, because I think I made that a little bit too long, as it were. Let's back it. There we go. That'll do. Right, so that's our stream. Now, it probably needs thickening up a bit, so again we can alter the width. Let's make it a little bit wider, so that's about right there. And we can even set the depth, and that actually has an effect in the game, because units can only forward a certain depth. So let's make that a 2 meter deep stream. So yeah, we've added our stream now to this historical map, and the idea is that when you come to distribute this, you actually not distribute this picture map. So if we go to here and turn off the overlay, so all you get is effectively the vector map itself, and that provides all the advantages of a vector map, in that you get terrain detection. So if I move my cursor over it, you can see it says stream, and of course you can zoom in as close as you want with no image breakup. Now this stream doesn't look it looks very artificial, it looks a little bit jaggy, but you can get around that simply by enabling Bezier mode for it, and that brings in the curves. So you see it looks a lot more natural in its curved state, and of course we can keep zooming in and zooming in and zooming in, and it all looks really pin sharp, and that is the big advantage of my system. Now if we were to view this stream from the picture, you'd see there's a massive amount of breakup. So if we enable the picture, then we turn off my my stream. So look at that, look how fuzzy that is, and that's what you get when you use a static picture for a map. Whereas by using my system, you have that ability to zoom in as close as you wish without any kind of breakup, and that I think is a very powerful feature of the system. So that's one way to use an overlay, and that's to create historically accurate maps in a very quick and accurate way. But another reason you might want to do it is you might, for instance, want to base your war game on a satellite map. So let's create a new map called sat map. Import an overlay, and let's go for extra large icons so we can see what we're doing. Alright, so where are we? That one there. So here's our satellite image. We need to locate the scale on it again. Here we go. So this one's got two scales. What we got? So the top one's feet, the bottom one's meters. So we use the bottom scale. So I'll switch that to kilometers, and we'll register this. There you go. Again, all we do is hit OK and OK. And the map's imported in at exactly the correct scale. Let's make that white so it fits in a bit better. Oh, whoops, wrong one, didn't want the scale. I wanted was the grid. Let's make that white. And then we can also tone it down a bit. So right now I could use this map in a game, and of course it looks quite different from all the other maps we've seen so far, that it's satellite based. But before you can use it properly, you actually have to register the terrain that you can see on this map, and it's all very simple to do, and I'll show an example. If you look at this motorway here, what we'll do, we'll recreate it from about here down to this interchange, just to show how easy this is. So I'll click add track, and try to make it Bezier based as well. And all you do, it's as simple as just clicking. It doesn't get any easier than this. So here we are, adding our road, and that's about far enough. So we've added our track relatively quickly there. I'm going to make it a little bit wider so it kind of fits in. So there we go. And as you saw with the other terrain, we can actually name it. So let's call that, I don't know, the N25 motorway. So that now has a name. Now you could distribute the map with the artificial road displayed like that, but if you were going make a satellite-based wargame, you'd probably hide this road by clicking that. So what you got here, the road's still there that we created, it's just you can't see it, but it means terrain detection still enabled. So if you look bottom left, as I move my mouse cursor over that motorway, you should see it, pick it up as the M25. There you go, bottom left, M25 motorway. So even though this is a satellite image, because I've registered this piece of terrain, it knows that's motorway. And with a little bit of patience, you can register every piece of terrain on this map and then use it in your wargame. And that has the advantage that after you've done that, you can use all the tools that come with the system. You can use like line of sight tools and everything. I can actually prove that by opening a map that I created earlier, as it were, using this satellite terrain. Now, where is it? It's one of these. Here you go, test sat map. There's a lot of data, so it's going to take a little bit of time to load. This will show you what can be achieved. Now, this test map, I rushed when I put it together because I didn't have a lot of time, but had I spent more time over it, I could have quite easily have made it to be a lot more detailed than it was. So there's a lot of terrain going in there at the moment. There you go. So this is a piece of terrain that I created based on that satellite image. Of course, all the line of sight tools work. If I do that, you can see that our chap stood there, can see partly into the forest, and his line of sight gets blocked. Up on the next contour, he still can't see anything, but the following contour up, you can start to see a bit more. And what you're seeing there's a little shadow zone there for the buildings that are in the way. So the line of sight works even for very complex terrain, as you can see there. And by having that overlay, it's allowed us to produce a map that's instantly recognizable as its original. That'd be very hard to do by hand otherwise. And of course, in this mode, you have all the other advantages, like I can keep zooming in and in and in and in and in and in and in, and there's no breakup of the image quality whatsoever. It just looks smooth. Now, if you look at the ground, we got, there are a lot of contours there. Map. That's linear terrain. All these terrain features are fully editable. Now, obviously, I haven't had time here to actually name them all, so they've all got weird names like track 1, track 2. So as I move my mouse cursor along, you see there my elevation 30 meters over woods 35 and contour 37. But of course, I could change that. Now, what you could do is you won't see the terrain because all of this terrain's over it. What you'd have to do is, if you wanted to use this as a satellite image, you'd have to turn off all of your terrain, essentially. Well, as an example, let's turn off the base ground level, which is this one here. And you'll start to see the satellite imagery poke through. And you just do that with everything else. You just hide it all. And the idea is you distribute the map with all these bits and bobs turned off. And of course the terrain detection still works, as does things like line of sight. So if I was to do a line of sight check across this hill ridge here, there you go, it's blocked as it gets up to the hill. And of course your end user won't see the artificial stuff. All they'll see is the satellite created imagery. But of course you'd have to turn off all the rest of the terrain features. So the mapping system is extremely flexible. It'll do satellite mapping, it will do its own standard mapping, and it provides many advantages over, I guess, a traditional system. Anyway, that's it. I've covered pretty much most of the things that the mapping system can do. And tune in for the next video. Thank you very much. Bye.